It's really cool to be part of this, and thanks to the commentators for their work. So Matt and I will present our paper, Compare and Contrast, on how to assess the completeness of mechanistic explanation. Do I still have to close anything here? Okay. So let's get to the talk. So there is this general agreement. Why does that look so weird? This is not the agreement. This is... Okay, let's ignore this. I hope this is not a problem. Okay, so there is this agreement that complete explanations are better than incomplete ones, and that the closer an explanation is to being complete, the better. Still, there is an ongoing discussion on what the completeness of explanation amounts to in the context of the mechanistic debate. And now, in the context of this discussion, some opponents of the mechanistic account have raised an objection. And this objection runs as follows. So it is argued that the new mechanists are committed to assuming that adding any kind of detail to the mechanism will improve an explanation. And for example, they're committed to the following. Mentioning quarks in the explanation of spatial memory will improve the explanation. And so that we can still hear them. Are we still, do we have to do anything? No. So there's still some noises in the background. Whatever. Okay. Perfect. Great. Okay, second example. So opponents of the mechanistic account say that the new mechanists are committed to saying that listing all kinds of activities of all billions of neurons in the brain will improve explanations in neuroscience, and mentioning the exact location of ion channels or mentioning the exact diameter of the axon will improve the explanation of the action potential. And obviously, these three examples show weird explanations, so it would be weird to mention quarks in the explanation of spatial memory and so on. And therefore, so the objection goes, the new mechanistic account fails as an account of explanation. And this is what, in a recent paper, Krickel and Kaplan call the more detailed, a better objection. And in the paper and in this talk, we want to discuss Krickel and Kaplan's reply to that objection. So here's what we want to do in more detail. So first, we want to say a little bit more on the MDB objection and Krickel and Kaplan's reply to it. And then we will introduce a helpful distinction. So in the paper, we say more on this, on why we need this distinction. For sake of a matter of time, we won't go through these three like tinier problems. We will just throw this distinction at you and show how it is helpful to make certain distinctions, and also show how it shows that actually two challenges still remain, not only for Krickel and Kaplan's account, but for the constitutive, for the mechanistic account in general. And these two challenges concern the relationship between constitutive and explanatory relevance and what we call vertical completeness. And then we will end with a summary. Okay. So let's start with the MDB objection and Krickel and Kaplan's reply to it. So in the paper, we argue that the objection that has been raised by different authors can be summarized as follows. So the opponents argue that the new mechanists are committed to three claims, namely A, explanations should be complete. Explanations are complete if and only if they describe every detail of a mechanism. And C, adding details about a mechanism to an explanation always improves the explanation. However, so they argue, often explanations are good because they leave out certain details of the mechanism. And therefore, based on the assumption that A sounds fine, so explanations should be complete, completeness of a mechanistic explanation has to be interpreted in a way that is less demanding than B, and C has to be rejected, as at least sometimes adding details about the mechanism does not improve the explanation. And thus, the mechanistic account has to be rejected because, so the objection goes, the new mechanists are committed to B and C. So now let's have a closer look at Krickel and Kaplan's reply to this. So again, their reply can be summarized as replies to each of these three claims. So strictly speaking, they argue that claim A, explanation should be complete, is not completely accurate. Actually, what the new mechanists are committed to is this. Completeness concerns stores of explanatory knowledge rather than models or explanations. The closer a store of explanatory knowledge is to being complete, the better. And they go on. Although a complete model is in principle possible, actual models serve further non-explanatory purposes, such as that such a complete model would fail to account for. So in a nutshell, models and explanations, although they could be complete, they usually aren't complete because they serve other non-explanatory purposes, but what should be complete or what follows the ideal of completeness is our stores of explanatory knowledge. Okay, with regard to sentence B, they also argue that this is not what the new mechanists are committed to, but rather the new mechanists are committed to the following. A mechanistic explanation or model is complete if and only if all details of a mechanism, if it mentions all details of a mechanism, and now the important bit, that are relevant for explaining a contrastive phenomenon P versus P prime. However, an explanation does not have to be complete in this sense in order to have explanatory force. If an explanation, however, leaves out relevant details, this will decrease its explanatory power and can only serve non-explanatory purposes. So the important bit is that completeness has to be relativized to relevant details. And now let's come to the last sentence. Also, this, of course, Krickel and Kaplan argue is not what the new mechanists are committed to, but rather this. Adding details about the mechanism to mechanistic explanations or models improves the explanation if and only if the details are relevant for explaining the phenomenon P versus P prime. So what this shows is that Krickel and Kaplan highlight this notion of relevance. So adding details improves the explanation only if the details are relevant. So what does relevance mean? So the new mechanists have discussed already extensively the notion of relevance and most importantly the notion of constitutive relevance, and especially according to Kohar Krickel, explanatory relevance in constitutive explanation is constitutive relevance, which is spelled out in terms of the so-called mutual manipulability account. Probably most of you are familiar with this, so just very briefly, according to the mutual manipulability account, a mechanistic detail is constitutively relevant for a given phenomenon if and only if the detail is a spatial temporal part of the phenomenon and both are mutually manipulable, if there is an ideal intervention on the detail by means of which one can change the phenomenon, and vice versa, there is an ideal intervention on the phenomenon by means of which one can change the detail. So what is important here and important to keep in mind for the rest of the talk, mutual manipulability here is defined for acting entities, so for accessifying and accessifying, where accessifying is the spatial temporal part of accessifying. Okay, so based on these specifications, Krickel and Kaplan introduced a norm of completeness, which is what they call salmon completeness. So here's how they define salmon completeness. The salmon complete constitutive mechanism for the phenomenon P versus P prime is the set of all and only the factors constitutively relevant for P versus P prime. So they think that out there in the world there is this constitutive mechanism which is salmon complete. That means it is composed of those factors that are constitutively relevant for the phenomenon, where the phenomenon is this P versus P prime. Okay, and now based on this notion, they argue that actually there is one version of the more detailed, a better claim that they want to commit to. And this is the following, namely the more relevant details are better claim. So if one model contains more explanatory relevant details, so this is constitutively relevant details, than some other model about the salmon complete mechanism, then this model has more explanatory force. Okay, so now our claim is that the general spirit of Craver and Kaplan's reply to the MDB objection is indeed convincing, because clearly only adding detail that is explanatory relevance for the phenomenon to be explained increases the power of an explanation. However, there are problems with the specifics of Craver and Kaplan's account, and he's on that.
Right, and one way to find out what the problems with the reply are and how to make it better is to start with this helpful distinction that we want to draw. And the distinction is between Quantic mechanisms, mechanism descriptions, and explanatory texts. So let's have a look at what that looks like right here. So we have these three types of things that have to be kept apart. So first there are Quantic mechanisms. And here you can see a picture of some neurons. Presumably some of them might be firing. These are the real things out there in the world that constitute the real phenomena out there in the world. They are kind of conglomerates of acting entities really interacting together in the world to produce the phenomenon in the world. Then there are mechanism descriptions. And mechanism descriptions, on our account, are texts or diagrams which have as their role to describe the Quantic mechanism which is out there in the world. And they should describe it fully, and they are not guided by any particular explanatory concerns. They are only aimed at neutral description of what the phenomenon is and what the mechanism is. And then there is another type of text on our account, which is the mechanistic explanatory text. And this is an actual explanans, and it is an answer to an explanation request. An explanation request is a why question, which asks why a particular phenomenon occurred rather than some contrast phenomenon. So, for instance, why did the neuron fire rather than maintaining resting potential? And so you can see that in our account, the contrasts only come in at this very last level of mechanistic explanatory texts. You can think of mechanistic explanatory texts as abstracting the relevant details for a particular contrast out of the mechanism description. Right? So the question then is, what information goes into these mechanistic explanatory texts? And do these texts always improve with the addition of further details? And as we will see, the answer to that question will surprisingly, or not so surprisingly, be no. Right? So to get there, we must now introduce the different norms of completeness. So norms of completeness on our account concern mechanistic descriptions on one hand and mechanistic explanatory texts on the other hand. And because we think that these are different types of texts which are aimed at different things, it makes sense that we need multiple notions of completeness rather than just one. And we say that there are norms for descriptive completeness on the one hand and explanatory completeness on the other hand. So descriptive completeness is relevant for mechanism descriptions. They obey the norms for descriptive completeness. And descriptive completeness can be summarized as follows. A mechanism description is descriptively complete if and only if it contains all and only the constitutively relevant details about the Quantic mechanism for phenomenon P. You can see that here the phenomenon P is characterized as just an acting entity. There is no contrast here to speak of. And you can see that because they deal with constitutive relevance, this notion of descriptive completeness will be quite demanding. And we can correspondingly formulate a version of this more relevant details are better claim, which is concerned with descriptive completeness of mechanism descriptions, and it goes as follows. If a mechanism description D contains more constitutively relevant details than some other mechanism description about the Quantic mechanism for a phenomenon P, then D has more descriptive power than the other description for P, all things being equal. And on the other hand, for mechanistic explanatory texts, there are norms for explanatory completeness. And these can be spelled out as follows. An explanatory text is explanatorily complete if and only if it mentions all and only the explanatorily relevant details for P versus P prime contained in the mechanism description. So the mechanistic explanatory text is created with the information from the mechanism description, and it mentions only the explanatorily relevant details for a particular contrast about the Quantic mechanism. And there is a corresponding version of the more relevant details are better claim for explanatory completeness, and it is the more explanatorily relevant details are better claim. And it goes as follows. If an explanatory text T contains more explanatorily relevant details for P versus P prime than some other text T star from the mechanism description for P and P prime, then the text T has more explanatory power than T star for P versus P prime, all things being equal. Now, very important to notice is that the notion of explanatory relevance that we are operating with here cannot be straightforwardly interpreted along the lines of the original mutual manipulability account. And that's because the mutual manipulability account deals with phenomena as acting entities, not with phenomena as contrasts. And the explanatory relevance relation deals with contrasts. So it is P versus P prime rather than just the phenomenon P. So we will need a new notion of explanatory relevance that we will have to present here. But we can already then, with help of this distinction, make the following diagnosis of what's kind of gone wrong in this debate between the opponents of new mechanism and Craven-Kaplan. And it is this. So the opponents of the mechanistic account may have confused descriptive and explanatory completeness. So they thought that mechanistic explanation just is mechanism description, which is not the case, we argue. That's it. But also, given that Craven-Kaplan defines summon completeness already with respect to contrastive phenomena, they themselves blur the distinction between explanatory completeness and descriptive completeness. And this is why it's important to then keep this distinction in mind when we try to reason about completeness of explanation. So hopefully that clarified some things. But now there are still these two challenges that we have to deal with. And one of them is this notion of explanatory relevance and how it relates to constitutive relevance. And the other one will be about vertical completeness, more on that later. Start with first challenge, constitutive versus explanatory relevance. So as I said, we need this new notion of explanatory relevance that is different from constitutive relevance because we need to not rely on that old mutual manipulability criterion when we talk about explanatory texts. So explanatory relevant details are contents of explanatory texts, as we said. Explanatory texts are answers to explanation requests, which are contrasted why questions. So far, so good. So for instance, you can have an explanation request, such as, why is some water frozen rather than thawed? The rather than thawed can be kind of read implicitly, and that picks out the actual phenomenon, a bunch of water is frozen, and the contrast phenomenon, a bunch of water that is thawed. But you can, with respect to the same phenomenon, formulate other contrasts, such as, why is this water frozen rather than evaporated? And the explanations, the explanatory texts for these two different contrasts will be different. So we need a way to figure out what goes into these explanatory texts. And we think that mechanistic explanatory texts should identify crucial points of intervention for turning the phenomenon P into P prime. So they should identify, for instance, the crucial point of intervention for turning a bunch of frozen water, a bunch of ice, into thawed water. And here, the crucial point of intervention is the point in which intervening would require minimal effort. Okay, so that kicks the bucket a little bit further. Now we need to figure out what minimal effort is. And we think that minimal effort is a function of the amount of interventions necessary and the similarity between these interventions. And because intervention variables are not always known, we will have to identify crucial points of intervention by looking at differences between mechanism descriptions. So what this is basically, sometimes you know what would have to be changed about a mechanism in order to turn it into a contrast, a mechanism for a contrast phenomenon. But you don't know how to do it. But we think at that point you can still explain why the phenomenon occurred rather than the contrast phenomenon, even though you cannot fully individuate the intervention together with the intervention variable. Right? But now, then we need to figure out how to compare differences between mechanism descriptions in order to be able to populate our explanatory texts. So here's how that would look. We have our explanandum there, why P rather than P prime, that identifies our phenomenon, our contrast phenomenon. And the explanans will be because some C rather than some C prime. And these C and C prime are sets of mechanism constituents. And how do we identify them? Well, here we have, I can't actually point, which is a bit difficult now, but here we have P, the phenomenon, and here we have the mechanism M, which is the constitutive mechanism for this phenomenon, and we can see that it's made up of the green blob, the yellow blob, and the blue blob. Right? So what we need to do is now we need to identify a description of some mechanism M prime for the contrast phenomenon that is most similar to the mechanism M. Here we have two candidates. Both of these are mechanisms for some token phenomena, token contrast phenomena, both of which fall into this class P prime. And we can see that M1 is made out of the green blob, the red blob, and the blue blob. And the other one, M2, is made out of the green blob, the red blob, purple, and what is that? Teal, turquoise? I don't know. Anyway, right? So both of these are mechanisms for a contrast phenomenon P prime. Right? So now we can see that M1 is more similar to the actual mechanism M than M2. And so what we should do is we should identify the differences between the mechanism M for the phenomenon and Mi, in this case M1, that are shared by all mechanisms for P prime. And we can see that these differences are that in the mechanism M, we have the yellow blob, and in the mechanism M1, we have the red blob instead. And the red blob is also occurring in the other mechanism for the contrast phenomenon P prime. So this is the relevant set of differences that is explanatorily relevant for the occurrence of the phenomenon P rather than P prime. The fact that in P the yellow blob occurred and in P prime the red blob would have occurred. Right? And so for a real world example, we can have a question such as, why is a car traveling at 90 kilometers per hour rather than standing still? And here we again have the answer, because C rather than C prime, and what are the C and C prime, where with the phenomenon car traveling at 90 kilometers per hour, we have a mechanism description. Those of you who have read the paper or will read the paper will recognize this format, but you can see a bunch of constituents listed here. So again, we need to identify description of mechanisms for the P prime, the contrast class, which in this case will be car standing still. And we need to see which one is more similar to M. And we can see here's one candidate, a car standing still with its engine running. And we can see that in this mechanism, the gearbox is no longer transferring any motion to the chassis. And we can see that in addition, there are brakes pressing on the wheels so that the car doesn't move. Then we have another candidate, which is car with its engine shut off. And here we can see that the engine is no longer running, the spark plugs are not sparking, the gearbox is doing nothing. The only thing that's left is that the windshield wipers are still wiping, and there are these brakes pressing on the wheels. So you can see that from these two, M1 is more similar to the actual mechanism M. So you need to identify the differences between it and the mechanism M. And we can see that they are the fact that in the actual phenomenon, the gearbox is transferring motion to the chassis, whereas in the contrast phenomenon, car standing still with engine running, we have the gearbox no longer transferring motion to the chassis, and we have brakes pressing on the wheels. So from this we get the explanation, why is the car traveling at 90 kilometers per hour rather than standing still? It is doing so because its gearbox is transferring motion to the chassis, and the brakes are not pressing on the wheels. I hope that makes it a bit clear. Okay, cool, will do. And we have a way to formalize this comparison slightly. So we propose that we can use a modified version of edit distances to figure out which mechanism descriptions are most similar to the actual mechanism description from all the candidates. So edit distances are used in computer science for string comparisons, and they just measure how many permitted edit operations are required to turn one string into another string. Because we think that mechanism descriptions are texts, we think that we can use a modified version of this framework to reason about them. Right? And there can be a weight or cost associated with some or all of the edit operations. And most commonly, the permitted edit operations on strings, anyway, are character insertion, character deletion, and character replacement. For mechanisms, there's a different set of edit operations that we propose, which you will find out about if you read the paper. But an example of this is the so-called Levenshtein distance, which just allows these edit operations. So inserting a character into a string to turn, for example, about into about, deleting a character to turn scurvy into curvy, or replace a character straight away for cost 1 to turn bloat into gloat. And using this, we can calculate distance between two strings, dogged to froggy. It takes 4 steps to turn dogged into froggy. And there are different words for which the distance is different, of course. Right, so we can use a similar framework for reasoning about mechanism descriptions, but more details on that really in the paper. But we are not done yet. So far, we can only account for what's called, what we call horizontal explanatory completeness. Already we're doing better than Craven Kaplan because they can only account for horizontal descriptive completeness with their account which relies on constitutive relevance. But we now need to talk about vertical completeness, and I hand back to Beate to talk about that.
Okay, so let's come to the second challenge and to the two notions that Matt just mentioned about the horizontal and vertical completeness issue. So one very important aspect of the new mechanistic account is that they highlight the fact that mechanisms come in levels. So you've all probably seen pictures like that, so that you can identify mechanisms at different levels for a phenomenon, where each lower level is again a mechanism for a component of the phenomenon at the top. And now we argue that the issue of completeness also concerns the question whether completeness is horizontal or vertical, where horizontal completeness concerns, roughly speaking, just one level, and vertical completeness concerns the question of how far down we can go. And interestingly, this shows that, and our previous considerations show that there are actually different notions of completeness here that we have to discuss. So in the first section, we have introduced the difference between descriptive and explanatory completeness. So here we talked about mechanism descriptions, and here about explanatory text. And what we now talk about is the vertical notion of completeness and horizontal completeness. And what Matt just referred to is that so far the new mechanists, so Craver and Kaplan maybe, and other people talking about constitutive relevance, what they are able to do is to, they deal with issues of completeness that only concerns descriptive completeness. And as we have argued, descriptive completeness requires us to add any detail about the mechanism. And this is why it can be accounted for in terms of the original mutual manipulability account, because any relevant detail about the mechanism is any constitutive relevant detail about the mechanism. So what we've argued for so far can also account for descriptive, vertical, and horizontal completeness. But then the first challenge was about how we can make sense of explanatory completeness, or rather how we can make sense of explanatory relevance that is relevant with regard to contrastively formulated explananda. And here, this was the first challenge where Matt just introduced our solution, how we want to make sense of explanatory relevance or explanatory completeness. And now the second challenge, one way to formulate it is to deal with the question of, so to speak, when is an explanation vertically complete? Or in other ways, at which level do we have to stop? And this is, if you remember from the beginning, our examples, the question, well, do we have to mention quarks when we want to explain spatial memory? Intuitively not, but how do we get there? So in other words, there are actually two versions of the MDB objection. So it can be read as a claim about the horizontal dimension of mechanisms, or as a claim about the vertical dimension of these hierarchies of mechanisms. And I think so far what we've discussed so far provides a nice solution for the horizontal version of this objection, but not for the vertical one. And the problem is that in contrast to mechanism descriptions, good mechanistic explanatory texts, they rarely go all the way down to the physical level. So good explanations in neuroscience, they don't have to mention quarks. But the question is where to stop. And constitutive relevance alone is not sufficient, already for the reason that constitutive relevance cannot be applied to contrast, but also that if we apply mutual manipulability, for example, to the issue of quarks and spatial memory, well, it is very likely that there is an intervention on quarks that will change, for example, spatial memory behavior and vice versa. So as a matter of fact, quarks are constitutively relevant to many phenomena in neuroscience. Now, Krickel and Kaplan, they do touch on the matter in a footnote, and there they offer a solution along the lines of Woodward's conditional irrelevance. So in what we want to do now is very briefly present to you how such an application of Woodward's notion to this problem would look like, and then argue that it doesn't work. So very roughly, if we apply Woodward's notion to this issue, this would look as follows. So Woodward argues that this second level is conditionally irrelevant for the phenomenon based on this level if the following holds. So assume we have a set of variables that represent this level and a set of variables that represent this level. And now first, both set of variables, they are constitutively relevant to the phenomenon, which is the case, which is why they build the mechanistic hierarchy. And second, if we keep the variables x fixed, then changes to y do not make a difference. So that makes sense. If we fix these components, we can wiggle this level and won't induce any changes in the phenomenon. Okay, so now Krickel and Kaplan's idea seems to be to apply this notion to this bottoming out problem. So where do we have to stop an explanation in order to be vertically complete? But the problem is the following. So the conditional irrelevance account of bottoming out fails for the following reason. All of the conditions are necessarily satisfied by all components below the first level of decomposition. That simply follows from the notion of the mechanistic level. But this is too restrictive because it would imply that we always have to stop at the first lower level. We never have to go even further down. But we should allow for the possibility that lower levels, so that are even lower than the first lowest level, of mechanistic decomposition, that they be explanatory relevant to the original phenomenon. Okay, so now based on this, on the insight that applying Woodward's notion does not work, the consequence is that so far there is no satisfying account of vertical completeness on offer so far. And now opponents of the mechanistic account could raise the vertical MDB objection, which would run as follows. Based on the new mechanistic account, an explanation of a higher level phenomenon is always improved by adding more constitutively relevant lower level details, so by adding, for example, mentioning details about quarks. However, explanations of higher level phenomena do not usually go down to the fundamental level, hence the new mechanistic account of explanation fails. But luckily, we have a solution for this problem.
All right, and I will present that solution. So the idea is that we can use the account that we have already developed about finding out the contents for explanatory texts to the problem of bottoming out. And then we get the idea of contrastive bottoming out, which is as follows. You go a level down if and only if at the lower level the effort of intervention to bring about the contrast phenomenon decreases or stays the same compared to the higher level. Right? So then we will need to compare the effort of intervention between different levels of the same mechanism description rather than between different mechanism descriptions. And we can use the same edit distance framework which was introduced earlier and which is spelled out in the paper to find this bottoming out level. We will compare edit distances between the mechanism description of the actual mechanism and the counterfactual mechanism description for the contrast phenomenon at various levels. So at level L minus 1, L minus 2, L minus 3. And that results in the following account of bottoming out. So bottoming out in mechanistic explanatory texts works as follows. Mechanistic explanatory texts bottom out at that level for which the edit distance from P to P prime is minimal in comparison to other available levels. And where there is a tie, lower bottoming out levels should be preferred because it's better to go deeper if it doesn't incur us any cost. Right? And there's a number of advantages to this view over competing accounts. So first of all, we think this is a good thing. It only offers us the feasible justification for bottoming out at a particular level. Because if we uncover more levels of mechanism as we kind of investigate the mechanism for the phenomenon further and further, maybe we can uncover a more systematic set of differences between the mechanism description for the actual phenomenon and the contrast phenomenon, which would allow for a shorter edit distance between these two mechanism descriptions. So we can only ever defeasibly claim that we have reached the bottoming out level. But it does not kind of implicitly favor higher or lower level explanations. It is always an empirical question where the bottoming out level is, and it can vary across disciplines or even across phenomena or even across contrasts relating to the same phenomenon. So it is now an empirical question rather than a conceptual question about, or a pragmatic question where the bottoming out level is. Yeah. And it may also explain similar bottoming out levels within a particular discipline. And this level would contain crucial points of intervention for contrastive explananda of interest to that discipline. And I will skip the example for interest of time, and we will move to a summary.
Yes, so I will now end with the summary. So what we did in this talk and in the paper is first we discussed Craver and Kaplan's strategy to defend the mechanistic account against the MDB objection, and we argued that it is promising, but it has some problems. And in the paper, we discussed more like this, also these tinier problems that for time reasons we haven't discussed here in the talk, but we argue that some of these tinier problems, they are avoided by using our distinction between ontic mechanisms, mechanism description, and mechanistic explanatory text. The further advantage of this distinction is that it shows that there are different norms, namely of a completeness, namely those for norms of description and norms of completeness for explanation. However, two challenges for Craver and Kaplan and the mechanistic account in general remained. Namely, the first challenge was how to spell out relevance for explanatory text or contrast, and secondly, how to meet the vertical MDB objection. And our solution, very roughly, was as follows. So in general, the idea is that mechanistic explanation is about finding crucial points of intervention, where crucial means, well, it implies the lowest effort to conduct these interventions. And we formalize this idea in terms of edit distance operations. Based on this, we could meet the second challenge, the first challenge, so we could spell out what explanatory relevance is with regard to contrastive explananda. And here we argued that we have to identify the lowest edit distance by comparing the actual mechanism to the most similar non-actual mechanism for the contrast phenomenon, and then mention only those components that distinguish the actual from the non-actual mechanisms, which are also shared by all the others, alternative mechanisms. And then we also provided a solution for the second challenge. So that was the challenge of vertical explanatory completeness. So where does an explanation have to stop, at which level in order to be complete? And here we argued that we have to stop at the level where the effort of intervening to produce the contrast phenomenon increases, or in other words, where the added distance increases comparing the different levels. And that's it. Thank you very much.